Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at copy elision and return value optimization. So I want to get on in a few tutorials to talking about R-value references, move constructors and stuff like that in C++11. But in this tutorial I want to show you what the situation is in C++98. So we're going to look at a C++98 project here. And I've added a special option to my compiler which turns off certain kinds of optimizations that you wouldn't normally want to turn off, because I want to show you what could happen in the worst case here, and later on in the next tutorials we'll look at how C++11 solves this problem in a much better way than C++98. So I've created this class here, and this is a very simple class. It has some basic constructors with just some text in them so that we can see when they're running. So we've got a default no parameter constructor. Here's a constructor that takes a parameter. I'm not sure if I'm going to use that, but I might do. Here's a copy constructor. We've got I've implemented the assignment operator, the destructor, and I've implemented the put-to operator, so we can use this objects of this class for cout, really just so that I can stop it outputting unused variable warnings. And all of these just don't do anything, they just output some text. Now the problem here arises if you do something like the following. So let's create a function which returns an object of type test. And let's call this get test. And in there, I'm just going to do return a new test object like this. So I'll construct it like this and just return it. Then we can use that function here in the main function by declaring a variable of type test. Let's call it test1 and setting it equal to get test. And just to shut up the unused variable warning, I'm just going to output this with cout as well, using my put-to operator. So if I run this now, the results are quite horrific. Let's take a look. So we've got a lot of stuff going on here. And remember, I've turned optimization off here. I'm going to show you this with optimization turned on shortly. So what's happening here is, first, in this function here, so remember C++ expressions are evaluated usually from right to left. So I'm guessing, I presume what's happening first here is that we're running get test. Well, I'm pretty sure actually. So in get test we construct an object like this, and that runs the constructor here. Then we return it. And you can actually think of the return type as being a sort of variable in itself, because when functions return objects, they have to copy those objects. At least this is true without optimization in C++98. They have to copy those objects into temporary return values, and that's why we see the copy constructor running here. We're copying this object into a temporary return value so that we can return it here. Then we see the destructor running, so that's the destructor of this object here, which is no longer needed. It's a local variable, so when it goes out of scope, it's destructed. Then we see the copy constructor running again, and what's happening here is that we're copying the temporary return value object into this object, so we're running the copy constructor of this object. Remember, if you declare an object and you set it immediately equal to something with equals, excuse me, it doesn't actually run the assignment operator, it runs the copy constructor. This is called copy initialization. So in this kind of situation we see copy constructors running. Then we're seeing another destructor, and that's the temporary return object being destroyed. Then we're seeing hello from test, which is the result of doing cout with this overloaded put-to operator. And finally we see another destructor, which is running because this object is going out of scope when we hit the closing bracket of the main function here. So what we wanted to do was we wanted to just have a function that can initialize this object in some kind of a fashion. This is a very simple and unrealistic example, but you often want to do that in practice in more complicated situations. So even though what we wanted to do is very simple, we've ended up constructing 3 different objects here and copying them all around using a copy constructor, which is clearly inefficient. So if you've been programming C++ for a while, when you see something like this, when you see an object being returned by value, you kind of feel that this is all wrong, that we shouldn't be doing this, because it could be very inefficient. Now, if you, at the moment at least, this could change of course, but if you Google copy elision or just copy elision by itself, the Wikipedia article at the moment actually shows you how to turn off certain optimizations with this flag in GCC, and I've added that flag to show you all this happening. If I go now back to GCC, right-click my project, go to Properties, and then here in the miscellaneous part of the build settings for the compiler, this is where I added that flag. So your compiler may or may not have this flag available, and normally you don't want to use it. So I'm going to remove that now, and let's see how the situation changes. So I click OK, and we click Run, and now we see that now we've got rid of all those extra constructors. We've got rid of all those extra objects, and the reason is that C++ can do something called return value optimization, which involves eliding or getting rid of extra copies of objects. So that this happens in a situation where you're returning some sort of local variable from a function like this, some sort of object, and you're using it to initialize another object outside of the function. Usually a C++ compiler can spot in that situation that you don't really want this object, and you don't want the temporary return object. You just want to initialize this object. So it's managed to optimize away and get rid of, and it does this by default, all the extra copies. It's elided those copies. We've got copy elision, and this is return value optimization. Now it's still not really considered good to do this in C++ 98. It's possible that your compiler, you might use some strange compiler that doesn't support this. More likely, you could code a situation where there's sufficient complexity in there, maybe somehow involving exceptions or something, although this does go on with exceptions as well. But maybe you could code a situation where the compiler can't spot that it can do that optimization, and you end up with this very inefficient business of constructing multiple objects where you only want one. So another situation where this could be problematic is I've included vector here, and let's go back to this, and let's go to properties, and let's add in that flag again. So I'll just copy it from here, and we'll go back to Eclipse and paste that in again to get rid of the optimization. So now let's create a vector of test. I'll just call it vec, and we'll do vec.push back test. I'll try that. I might need to use the parameter form of the constructor. Let's see what that does. So here's hello from test. That's coming out from here. And now again we've got a constructor and then a copy constructor to first we have to construct the object, and then we copy it into the right slot in the vector. So again, this is quite inefficient. And C++ 11 actually solves this problem using something called R-value references, move constructors and move assignment operators. So in the next tutorials, we'll go on to taking a look at that. So that's it for this tutorial. If your compiler supports turning off return value optimization, then it's worth trying this for yourself. It's just interesting to see. and then we will go on to looking at how we can avoid this. So until next time, happy coding.